Hey everybody, we're back again for another C++ lesson with my son Alex. How's it going, Alex?
Hello, everyone. New location.
That's it. New location, but another important C++ lesson. And this is going to be one of the most important ones. I always say that they're important. This is a very important one today. So today we're going to make an introduction into the world of debugging. Debugging is a very big subject, and it's one that I don't see a lot of tutorials out there for, but we're going to give an introduction because I think that there that is quite important, and we're going to talk about it today. So, have you ever heard of breakpoints or assertions?
Yeah, I've talked about it with other developers before. I've worked with it in a few programs already, so yeah, I'm kind of familiar with it.
Awesome, cool. So, I'm going to go ahead and share my screen, and just going to bring your picture over here and hit play. So, this I always say this about our lessons. This should be a pretty short one, but this is just going to be an introduction. So, this is something that can get quite deep, but I'm just going to give you the very basics on in this very first introduction. So once again, we're talking about debugging, and in particular, we're going to talk about breakpoints and assertions. So I'm going to give a high-level overview of what those are, and today we're going to do a practical walkthrough. We'll just jump straight into the code. So what are breakpoints and assertions? So a breakpoint is a tool that is in our IDEs, so Xcode or Visual Studio. Most IDEs have something like this, and it's a tool that allows you to pause the program execution and inspect the state of your application. So what that means is that as your code is going through function calls, you can actually set a point where you want your application to pause, and you can actually inspect what your variables are at that one particular moment in time. And then if you want, you can actually continue execution if you like. Okay. Any questions on that?
No, it seems pretty clear.
Yeah. Now, an assertion is a macro, and a macro is just a fancy word for a piece of code that evaluates a statement. One statement could be something like X is not equal to zero. And if that statement is false, then the program will abort. This is a handy tool that we can use to ensure that our code is valid, or that we're getting values that we are expecting them to get at a certain particular point in time. And if those values are not what we're expecting, then the program will actually stop execution and say, hold on, this statement is false, and your program will abort. So that sounds like a wordy way to explain this, but I think it will make sense when I actually show you the code. So now we're just going to go through a walkthrough. And these are powerful tools. So let's take something like this, right? So let's just make an int a, and let's just set it equal to 10. Now, a lot of beginners, such as myself when I first started, uh, if I wanted to inspect what the variable is at a certain point in time, I might just do a console out. And that's something that we've done many, many times before, where we just console it out and we see that the value is 10. Or if we said a plus plus, we can see that the value is equal to 11. Sometimes what we'll do when we're doing more complex programs is maybe we want to see what that value is at two particular points in time. So we might want to see it before it does something, and then after it does something. And then we will get something like this. So A on line 14 is a value of 10, and A on line 16 is a value of 11. So that's the way that we do things to start off with. So another way that we could do this is by setting a breakpoint. And this is done differently and depending what sort of what IDE that you're using. In Xcode, you do it just by clicking on the line number, and in this case, I'm clicking on line 13. And what it will do is it will actually pause the execution of the program on line 13. So we hit build succeeded. Now we have down here on the bottom left, we have this inspector. And the first thing that you'll notice is that if we look here, we see that A is actually, can I make that bigger? Don't think I can make that bigger, unfortunately. What we see here is that A is not 10, A is 1, which is strange. Do you know why that might be, Alex?
I'm gonna guess that it's because the execution paused at 13, meaning that it was never actually changed to 10.
That's correct. Yeah. So what happens is that, and this is a common mistake or a common misnomer when people first start getting into debugging, which is that they look and they try to pause the execution or hit the breakpoint on line 13, but line 13 hasn't actually run yet. So the value of A at this point hasn't been initialized to 10. And what we may see is if I hit it again, it may be a different value, maybe not. So, but the value is undefined at line 13. Now we have a couple of tools, and once again, these are quite standard tools for just about any IDE that you use. And what we have in here are play, which means that if I hit this, this will just play. This will just play the program execution and just continue it after the breakpoint and just continue to the end of the program. You have step over, which means that it will go to the next line. And then you have one that's called step in, which is if this line of code was to call a different line of code. So sometimes you'll have one function call that calls 2 or 3 other function calls. And you could do what's called stepping in, which means that you step into the function call, and then you can step into the next function call and actually inspect what's happening line by line as you go down what's called the call stack. And that could get quite complicated when you start getting into frameworks and start getting into larger programs. And then you have step out, which means that you would step out. So let's say this int A, let's say hypothetically, this was a function call that had another function inside of it. You could step in, you could inspect the values of those variables, and then you can step out, which would bring you back out to the int main thread and continue down where you can hit play or you can step over. So yeah. So if we most simple use case here is stepping over. So which means that we just execute the code line by line. So once again, A is initialized to this undefined value. In this case, it's 1. And then if I hit step over, oh, sorry. So if I hit step over, then we see that on line, now we're on line 14, and we see that A has been initialized to the value of 10. And then now we get the line A++, which means that now A has become 11. And then that's it. If I do this, then it'll just get step over failed because that's the end of the program. Okay, any questions so far about that?
No, not any questions, but there's a strange phenomenon in Visual Studio where if you step over, or like if you try to have a breakpoint on a line which initializes a variable, like on line 13, you'll have these crazy numbers like negative 1 to the power of like a million, something ridiculous. And it's
Yeah,
very strange.
yeah, exactly. And the reason for that is because once again, even though we're getting that neat number, that number one there, it could very well, like if I just, let's say if I just said this int a, and then I hit this. Oh, sorry. I need to hit a breakpoint. Oh, that's the other thing. You could hit multiple breakpoints as well. So now let's do that again. Oh, it still initializes to 1. So what if I said this? Oh, I'm going to get an error. I'm going to try to just access a different point in memory. No, it's still going to be 1. Yeah. So what you're doing is before you actually execute that line of code, A is creating a space in memory. A is a space in memory that hasn't been initialized to 10. And that is just going to be just random. It could be anything. So that's why you're getting those strange numbers. Okay.
Now, actually, I do have one question now that I think about it.
Yep.
So if you have multiple breakpoints, let's say you have 2 breakpoints,
Yep.
and you continue from the first breakpoint, would it stop again at the second breakpoint?
Yes, it would. Yeah. Yeah. So if I did this and then instead C out, I am Josh. And then A plus equals 10. And then I set 1 here, and then I set 1 here. We will get a breakpoint there, right? And then if I hit play, then we get a second breakpoint there. And that's that can be very useful in certain circumstances. Okay, does that answer your question?
Yes, it does. I'm curious how this would affect larger applications like apps. Suppose, I mean, I'm not familiar with app architecture too much, but suppose you have like a bunch of code that creates an app and then you put a breakpoint in the middle of it. Would it just not create the app? Like, would it half construct it and then leave the rest until you actually continue it?
Well, let's find out, right? So before I do that, I want to call your attention to one other thing, which is over here on the left. And this isn't going to mean much to you at the moment, but when you get into more complex applications, this will mean a lot to you. So we see this thread 1, and we see this 0 main, 1 start, and then 2 start, and what we have here is what's called assembly code. But this is what's called the call stack. So in larger applications, you have multiple threads. So sometimes you have up to 25 threads that are all doing all kinds of different things. And sometimes what'll happen is that your program will pause or it'll have an error in one of your threads. And what you have to do is you have to actually go back through the call stack to actually see where the mistake has occurred. But we will go deeper into that as we go into our first framework in the next couple lessons. But let's add a layer of complexity to this, right? So so I'm going to show you a little bit more about how breakpoints are useful. So let's start with a function call, right? So let's say that we're just going to have a function called add. And what it's going to do is it's going to take an input and it's going to add 1 to it. Let's say, just for the heck of it, that we have int b, which we will set to 5. And b, we can do b plus equals 32 there, right? So now we have this int a, and now I'm just going to make the function call to add, and I'm going to input A. And then what I'll do is I'll do a little console out here at the end. Okay. So now we have something that's just a little bit more complicated, not too complicated, but now we've set a breakpoint once again into int A. We see that A has been initialized to 1. Remember that this could be any value because this piece of memory would not be initialized at this particular point in time. And then we hit step over. And now we have the function call to add. Now, since this is a function call, what I could do is I could do this step into. And that brings me into add. Okay. And we can see that we have this, this int b, and we see that once again, it's been initialized to a value. At this point, the value of this memory location is 0. And that's because we haven't actually executed line 13. Another thing to take a look at is our call stack. So in our call stack, we actually have this, we actually see that we are in this function called add, right? And now what I can do is I can do step over. And now we see a couple things, okay? So taking a look at our inspector, we can see that X is at this particular point in time is 10. We see this hex number, which is actually the memory location that X is actually, that A is actually located at, because remember, X is a reference to A. And we see that now we have B, and B has been properly initialized to 5. And then if I do step over again, we see that X has now become 11 because we did X plus plus. And B still hasn't had the 32 added to it because line 15 hasn't been executed just yet. So I want you to watch over here on thread 1 what happens when I hit step over again. So now what happens is that, yeah, so one more. B is now 37, X is 11. And then if I hit step over, watch what happens in thread 1. You see how add just isn't on the stack anymore? Alex?
Yep.
Yeah, so you see how add was there in the call stack, and then when I finished the function call, that it actually removed it.
Yep.
So that's called popping off the call stack. So what happened was that you had int. If we just started at the very top, we have int main. Int main calls add, and then what happens is that the function add gets added onto the call stack. So think of it almost like a pancake that gets put on top of main, which is the first pancake. Then add does everything it needs to do. And then what happens is that that pancake gets eaten up, or it gets popped off the call stack. And now you're back into main. And now you can see I'm back in line 23. Okay. And then once again, we see that all of our variable A is 11 at this point. And if I step over, then we get our console out, I am Josh.
So in the case of Stack Overflow, is it basically never popping off the stack? It's just infinitely stacking on until it's overloaded?
That's correct. Yeah. So Stack Overflow. So you have the call stack, right? And what Stack Overflow means is that now you have so many things that are happening on your stack. It's actually overflown your memory. So that's what Stack Overflow is. It's where your call stack has been overloaded, basically. That makes sense?
Yeah, it seems like a rare phenomenon, but I've actually run into it more times than I would like to admit.
Yeah. Yeah. It's something that happens quite often. Well, it doesn't happen often, but it's something that can happen. So just to run through that again, if we hit step over, so if I did step over, and so now I'm on add, and I did step in, which stepped into the add function, and then I was able to inspect what was happening in the add function. So once again, I'll do step in, and once again, make sure now we can see that B has now been added to our list of variables, right? But then if I step over, and step over through the add function call, once add has gone out of scope, then once again, you see over there on the left that add will disappear from the call stack. And we see that B has also disappeared because B is no longer in scope. B no longer exists in the program. Okay. But you could also, if I did that without stepping, if I went through this without stepping in, so if I do step over, oh, I didn't mean to do that. So if I do step over, interesting that it did that. I don't know why I did that twice. Let me try that one more time. So I did step in before, which stepped into the add call itself. But if I do step over, you see that it won't actually step into the add call. It'll just step over it, and it'll make A11. So you see that? So
Yep.
now we're on line 23, and it didn't actually go into lines 12 through 16.
So I
Okay.
remember we were talking about constructors and destructors a little bit ago.
Mm.
And so in the case, let's say you make an error and you never destruct the constructor, if that's the right terminology. Is that just permanently on the stack, taking up resources?
That's correct. Yeah. So that would be more in the use of when we're talking about pointers and dynamically allocated memory. So sometimes you have memory and things that you allocate that maybe you don't want it to last the lifetime of the application. And if you're using raw pointers, then what can happen is that you can end up in a situation where you have an object that is taking up memory, and you don't have any, and you're at a point in your application where you can't actually even access it anymore to be able to destroy it, but it's still taking up memory. So yeah, so it wouldn't be something that would be on the call stack, because the call stack is specifically for like function calls, not so much for like dangling pointers and memory that you want to unallocate, but is more for function calls more than anything. Does that answer your question?
Yep, got it.
Yeah. So, okay. So now let's take it one level further. So let's talk about a class. So this is another use. This is another great use for using breakpoints. So let's say that we have this class car and we have some sort of method. Let's just call it drive. And we aren't going to put anything in here at this point. And let's say that we have a couple private variables. Let's say int num wheels. We'll set it to 4. We'll say int max speed. And let's just set it to 60. And then now what I will do, and this is another great use for breakpoints. So now what I'll do is I'll create a car, and then I'll just call car.drive, which doesn't actually even do anything. But what I could do is I could set a breakpoint here. I don't know why my mouse is acting so strange today. So now I'm going to, oh, I need a semicolon there. And so now what we can see is that we have this car that we're getting ready to allocate. And now we see once again this when we haven't actually initialized our variables or actually run this line 23 yet, we see that we're getting random numbers here. So we can see that num wheels is actually 53,285 rather than 4. But what I wanted to show you here was that how breakpoints could be useful, because once I run this, once I do a step over here, we see that we can actually see what the state of these variables are. But if I tried to, because these variables are private, I wouldn't be able to console out what that variable is in int main. So that's one of the big advantages that we have with using breakpoints over just trying to console things out. Consoling things out is nice, and sometimes it's great to do. But I try to use breakpoints. Breakpoints is kind of it's a great tool for when you're trying to inspect what the value of a or what the state of your application is at a certain point in time. So we see here that we have car, and we see here we have this little arrow that we can fold up and fold down, and that in car, if we had loads of different variables, member variables for this car, we would be able to see what the state of those is at any particular moment in time. In this particular situation, it's quite simple, but as you get into frameworks, this ends up getting very complex, and you will see very soon how complex these things get. So, any questions on that?
Yeah, so this is not directly related to breakpoints, but I was curious about, I was trying to explain to someone new to C++ the exact specifics of how memory was actually allocated when you're coding. So for example, how when you actually create an object, there's a space in memory, but when you create a function, it does something. I wasn't sure what I said at the time, but in this case, I'm curious about the state of int num wheels in terms of its physical allocation. So because it's not an actual object yet, I'm assuming that it doesn't technically exist in memory. Like you can't go into int main and say console out num wheels because it's part of an uninitialized class. So does that mean that the class car template, you could call it, has a space in memory with all this information, and then when you create an actual object, it derives from that template? Or
so how to answer this question? So think of car as a user-defined object. So we have this int that is what we would call a primitive, something that is defined in the C++ standard. So car is I don't want to say it's like it. It's two different things, but it is something you have created, right? And and when we create a car, this car, what happens is that it looks at all of the things that we need for a car. So we need an int for num wheels. We need an int for max speed. I believe an int is 8 bytes on most computers. So in this particular situation, I guess it would need to allocate 16 bytes to create a car. And so it would create that space in your memory. Does that answer your question? So what it does is it allocates a space in memory for your car and everything that car contains.
right. So does the class itself have any space? Like because I'm
You mean
getting the
if I
impression.
don't create a car, if I don't,
Yeah,
if
if
I
you don't
don't do
create it,
that?
yeah, that's what I mean. Yeah, the
No,
actual class
no.
itself.
Yeah. So at this point, at this particular point, I've defined car, but I haven't created a car. So car is just kind of a template that I've defined, and I've defined what it is. But at this particular point in time, no cars have been created, so no memory has been allocated. So a car does not exist for all intents and purposes. It's not until I do this and then I execute that line of code that a car actually exists. Okay.
So, okay, in theory, could you create an infinite amount of classes and have it not affect the performance? I mean, that's a weird question, but
Yes. Yeah. I hope nobody else I hope no experts call me out on this, but yes, that's correct. As far as I'm aware, that is correct. When you, so you could take these classes and you can define as many classes as you want. At this point, it's just text. It's like a recipe. It's a recipe that you've written down, but nothing has actually been created until I create it in int main.
got it.
Yeah.
Mm-hmm. Mm-hmm.
Cool. So, any other questions on debug on breakpoint specifically? And then,
No.
okay, great. So now I'm going to show you another tool, which is called an assertion. So assertions are also great. So first thing that we need to do is we will need to include a new header called assert.h that will give us access to assert. So assert, it looks like a function, but it's not actually technically a function. It's what's called a macro. Macro is kind of a piece of code that you run. I guess it's kind of like a function call, but technically it's not. Um, so let's look at something very simple for an assertion. Assertions are fantastic, and I love using them, especially when you're using larger programs because they essentially ensure that your variables are in a state that you want them to be in at a particular point in time. So I will give you an example. So let's say that once again, we create this int a, and let's say that we set it to 10. And then what I could do is I could do this, what's called assert. And then I could say, and then in here, I'll make a statement. So let's say that I said A is not equal to 10. Okay. Now, if I execute this, if I run this, what'll happen is that we hit this program assertion, and that our program has actually stopped execution. The reason is that this assertion ensures that our program is in a is that this statement is true. So A is 10, and what we want to do is in the assertion we want to say what we the statement that we, how can I say this? This starts getting confusing. So in the assertion, I want the statement that I want to be true inside these parentheses. So in this case, I've said, okay, I don't want A to be 10 in this particular situation. And that's what's happened, is that it stopped execution. So so I know what you're probably thinking. How is this useful, right? So let's do something like this. Let's say that we created a function. Let's say let's do like float divide, and then we said uh, let's see, float denominator, and then I say, let's do this. Sorry, float numerator, float denominator. And then I say numerator divided by denominator. And I could just return that directly, just like that. Okay. And then let's do auto A equals divide. And then looks like the standard library has its own divide by function. So I'll do divide by just to make it divide by. And then here, let's just say 10, and let's say 5, just to make sure that this works. And we will set a breakpoint to see what this actually is. And we see that we get 2, right? So that works. That works fine, right? What if I make this 0? Oh, we still get, it actually builds. That's not what I expected. Okay. But one of the big things, so we see here that we got infinity, right? Probably something that we don't want, right? Are you with me so far?
Yep.
Okay. So we know one of the classic computing rules is we don't want to divide by 0. And this is especially dangerous because we see that this still executed just fine. And if we were expecting, let's say we were expecting some sort of audio input and that was infinite, some sort of infinite gain, then that would be really, really loud and really unpleasant for our user, and probably blow their eardrums out, which would be a bad experience. So what we may want to do is we may want to say, okay, we're going to put an assertion in here, and we're going to say denominator can't equal 0. Okay. And now we're going to do this again. And see, now we hit the program assert, and it says, oh no, you said that you don't want your denominator to equal 0. And we can see that in our inspector. So this is something I forgot to mention in about breakpoints and debugging, which is that you can actually hover over the variable and it will actually show what the value of it is. So we see that that's 0. And so this is a way that we can actually test to make sure that our inputs and our values and the values for our functions are valid in what we expect them to be. And where we can actually pause the execution of our program. And it's almost like a test that we define for ourselves. And we say, hey, we want to make sure that denominator is never 0. And if we do, then we want to pause the program execution and say, hold on a second, there's a problem here with this code. Okay. Is that clear for you?
Yeah, I was actually curious if we could see the definition of assert.
The definition as in like going in here?
Yeah.
There you go. Yeah. So it's a little bit complicated. I don't know what that actually all means. That's a little bit beyond my pay grade. But yeah, there you go. That's what
that is incredibly dense.
Yeah, that's pretty dense. Yeah, but that's what an assertion does. Okay. And you can do loads of different things there. So you can make, it's not just making sure something isn't equal to something. You can make sure something is equal to something. So if I said bull is alive, I set it to true. And then I could say assert is alive is equal to true, like that. And if I hit play there, I think we will be fine. So see that asserted just fine. But if I if I didn't want this entity or whatever it is to be alive at this point, then we see that we hit this assert. Uh-oh, is alive is true. And we can see when I hover the mouse over the inspector, over the variable, that is alive is true now. And we didn't want it to be true at this point.
So I noticed that it says thread one hit an assert. So does that mean that it basically quote unquote kills that thread?
That's my understanding. Yeah. So this for me, this would mean that what you could do is I think you could do this in the main C++, is you can actually just hit. So this assert is like actually a test for you, but you can actually hit play and it would, oh, maybe it wouldn't do that. Yeah, never mind. Disregard what I just said there. But yeah, essentially I guess it kills the thread. I'm not exactly sure. Seems like it does. So
because you were mentioning programs with multiple threads, and so if it quote unquote kills a thread, then I'm wondering what the effects of that would be. I don't know if threads are independent of one another, like as in you can have thread 1 and 2 completely independent of each other, even if one dies. So it doesn't rely on the other, basically.
oh well, they do. Yeah, it doesn't. It's not really like that, because if you have multiple threads, then let's say we had two threads, those two threads are likely doing different bits of work at different points in time. But sometimes they have shared this starts getting into a much more complicated thing, but sometimes they'll have shared resources. So imagine a thread. Imagine you had two threads, and those threads were, let's say that they were cooks in a kitchen, but they had a shared resource, which is, let's say, a pizza oven, right? Which means that each cook, only one cook could use the pizza oven at a time. And so you get into things like that, like which thread is using a resource at what particular time, or are both threads trying to use the same resource at the same time, and then you get what's called undefined behavior, because you're not sure which one is actually going to be able to get in to change the resource before the other thread. So you get into what's called data races and things like that. So it gets pretty complicated. Yeah, but yeah, that's exactly why I'm introducing you to these subjects right now, so that when we start getting into more of these complicated applications, you'll see as we get into other frameworks that how having these tools, like being able to use assertions and breakpoints, helps us see what's happening within an application at one particular moment in time.
That's pretty dense. How did we get from breakpoints to threads and
because you were talking about if a thread gets
oh
killed.
yeah, if the thread terminates, does it affect it? Yeah, okay.
Yeah.
Right.
So you're getting into some questions that I don't particularly know the answer to, that I could probably have theories about, but I'm not 100% sure. So yeah, so that's it. That's breakpoints and assertions 101. But this is, once again, these are two tools that you can use, and they will be very handy. And breakpoints, they get into that you can do a lot of different things with breakpoints as well. You have things like what's called conditional breakpoints, where you can, let's say that we had something that was happening 1,000 times. You can make it where the breakpoint only happens on, like the 500th time and things like that. So yeah, there's actually a whole other in Xcode. There's this whole other language that's written within within all of this called LLDB, which is a whole other language that you can use to actually inspect the values of the application at certain points in time, and it gets pretty complex.
Yeah, see, the more there's a term for this, but the more I get into programming, the less I know, or the less I realize I know.
Yeah, the same here. Yeah, yeah, exactly. The more you think you know, the less that you actually know, and the more that you realize that you know nothing, the more that you know. That's the saying is something like that.
Mm.
Cool. So that's where we're going to end this tutorial, and I hope you found this helpful. Please give a like and subscribe if you're watching at this point, and we will see you next time.
Peace.